Okay, we're told that chlorine at room temperature is a green gas, bromine is a red-brown liquid, and iodine is a grey solid. And we have to predict the appearance of astatine, which is the next one down in group 7, the halogens. Okay, well, chlorine is a gas, bromine is a liquid, iodine is a solid. They're getting more solid, if you like, as you go down. So, pretty safe bet, it's going to be a solid. AT is astatine, by the way. Okay? Now, what about the appearance? Green to red-brown to grey. Look, this isn't a brilliant question, okay, but they're kind of getting darker, aren't they? So, let's say it's going to be black. Okay, that's what they're looking for in this question. Just for 1 mark. Astatine is probably going to be solid, and it's probably going to be dark grey or black. Okay, you're just looking for patterns, that's all. Right. The order of reactivity of chlorine, bromine and iodine can be determined by carrying out displacement reactions. Explain how displacement reactions can be used to show the reactivity of these 3 elements. 6 marks. Okay, so we've just got to churn out our knowledge about displacement reactions and get 6 marks. Well, firstly, let's make sure you know that in group 7, the halogens, as you go down the group, reactivity decreases, okay? And as you go up the group, reactivity increases. So you should enter this question already knowing that chlorine is the most reactive, then bromine, and then iodine. Out of these 3, okay, this question is only asking us about these 3, not astatine. Iodine's the least reactive, chlorine is the most. Okay. Right, so, got to get 6 marks. How shall we start? Well, it's about salts, okay, and adding the pure halogen, such as Br2, bromine, okay, to a salt of one of the other halogens. So start by saying that a more reactive halogen displaces a less reactive one from a solution of one of its salts. Okay, so that's what this whole question is based on. I'm not going to write out the whole sentence, don't have time, okay, don't want this to be an hour long, this video. So you should write it out, okay, because in the exam, but a more reactive halogen displaces a less reactive one from a solution of one of its salts. Okay, so a more reactive halogen displaces a less reactive one from a solution of, I pretty much have written the whole thing, okay, solution of one, what was it? Solution of one of its salts. It's salts. Okay, so it's all based around that. I'll try and write less for the rest. Okay, so you've got to know that. You've got to know that chlorine is the most reactive, iodine is the least, and you've got to know that to be able to answer this question. So learn that now. Okay, right. So next, say, let's decide which is more reactive, chlorine or bromine, okay? So add aqueous, because at room temperature chlorine's a gas, it has to be aqueous. Add aqueous chlorine to a solution of bromine, sodium bromide. Okay, good. Right. So that solution will be clear. It's just a salt dissolved in water. When you add the chlorine, because it's more reactive, the chlorine displaces, use that word, displaces the bromine, okay? And it forms sodium chloride and Br2, okay? The more reactive one displaces the less reactive one. You've got to know that, okay? So, write out the equation. Chlorine is diatomic, so it's Cl2. Okay, these are all diatomic in their pure elemental form. Cl2, Br2, I2. So, chlorine plus sodium bromide goes to Br2 plus sodium chloride. Okay? Balance it as well. We're going to need a 2 there and a 2 there, I believe. 2 sodiums, yes. 2 bromines, yes, that's correct. Good, okay. And say what you would see. How do you know a reaction has taken place? Well, you've now got bromine in solution, and that makes an aqueous solution, water, bromine in water, it makes it turn sort of orangey brown colour. So the solution turns orange brown. Okay? So you see this colour change because it turns orange brown from clear. And so you can conclude that a reaction has taken place, or a displacement reaction has taken place, and therefore chlorine is more reactive than bromine. So displacement has happened, and therefore I'm going to swap pens because this pen is running out. And therefore you can say that chlorine is more reactive than bromine. Okay? Do you get the idea? So we're well on our way to 6 marks. Probably got at least 4 marks already. Okay? Now, to get the full 6 marks, we just need to repeat that with bromine and iodine and prove that bromine is more reactive than iodine. And then if chlorine is more reactive than bromine and bromine is more reactive than iodine, chlorine is definitely more reactive than iodine. We've got all 3 in the correct order. So just repeat. So we would add a solution of, or we would add, at room temperature bromine is already a liquid, so you could add pure bromine if you like, or it could be an aqueous solution of bromine, doesn't really matter. So you add Br2 to a solution of sodium iodide, balance it. The bromine is more reactive than the iodine, so the bromine kicks out the iodine, and you would get I2, pure iodine, and 2 sodium bromides. Okay, same thing. And in this case, the aqueous solution of sodium iodide, again, it's a salt, it would be clear, and it would go, iodine makes it sort of a dark red colour. Okay, so it would go dark red. Same thing, blah, blah, blah. Therefore, a displacement reaction has taken place, and therefore you can conclude that bromine is more reactive than iodine. Okay? And to wrap it all up for the full 6 marks, just say, if chlorine is more reactive than bromine, bromine is more reactive than iodine, you can put all 3 in reactive order. Chlorine then is more reactive than bromine, which is more reactive than iodine. Oh, Christ. Okay, 6 marks. There you go. Right, let's move on. What have we got? Right, so you're reacting iron with bromine for this next question. And we're told you've got 5.6 grams of iron and 24 grams of bromine. And you have to work out the formula of whatever's made. So, this is what's going on. You have iron plus Br2 and it's making iron bromide. FeBr. Well, iron can be iron 2 or iron 3, so there may be 2 bromines on it, or 3. We don't know. That's the whole point of the question. Is it Br2? Is it Br3? We don't know. That's what we're going to find out, okay? So write out the equation, and you don't have to get that right yet. Like I say, it's the whole point of the question. But write it out because you have to write underneath, in columns, everything you know about that particular reactant, okay? Now we're told that we have 5.6 grams of iron, so write it underneath the iron. We have 24 grams of Br2, so write that underneath the bromine, okay? Now, they also tell you that the atomic mass of iron is 56. In other words, it weighs 56 grams per mole. Write that underneath. Iron is 56 grams per mole. And write it like that. Don't do it grams at an angle mole. Write it like this, for reasons that will become clear in a minute. Okay? Now, we're also told that bromine is 80 grams per mole. Okay? The atomic mass of bromine is 80. Be careful here. Br, okay, I'll just explain this. Br itself, a single bromine atom, is 80 grams per mole. But we've got Br2, okay? So you have to write the molecular weight. Br2 is therefore 160 grams per mole. Okay, so write that in. Grams per mole. Do we know anything else? No, we don't. Okay, so we're ready to go. Now, when you do it like this and write in columns underneath each one everything you know, in one of the columns there will always be 2 things, in which case you can work out the third every time. You don't even have to think. Whichever column has 2 things in it, work out the third. And in this case, there's 2 columns and 2 things in it, so we can immediately work out the third thing here and here for both columns. So let's do it. Right, we've been given grams. We know the grams per mole. So looking at these units, we know that if we do, in fact, I just need to draw a line there, don't I? If we divide that one by that one, we've got grams on the top, grams on the bottom, so they cancel, okay? Now when you divide and divide again by something, that's the same as that flipping up to the top. So we end up with something in units of moles, which is what we want. So in your calculator, or in your head, if 5.6 divided by 56, that's 0.1 units moles. Write that in the column. We therefore have 0.1 moles of iron. Okay? Same thing with the Br2. You've got 24 grams and 160 grams per mole. Divide that one by that one. Grams on the top, grams on the bottom, they're gone. Divide and divide again by moles, that flips up to the top. And we've got 24 divided by 160 moles. 24 divided by 160 is 0.15 moles. Okay? Great, we're pretty much there. We know we've got 0.1 moles of iron and 0.15 moles of Br2. So, that means the ratio of iron to Br2 is 0.1 to 0.15. Okay? Let's multiply these by 10. We're trying to make these nice whole numbers, okay? We can multiply both by 10. It's a ratio, it's like a fraction, okay? So that's the same as 1 to 1.5. We've still got a decimal, we don't want that. Let's multiply both of them by 2. So that's the same as 2 to 3. That's better. So we've got 2 ions for every 3 Br2s, okay? So that's like 2 ions to every 3 Br2s, okay? Notice I've kept this 2 here, the little 2. It's Br2 that's reacting, so we've got to include that. You can't just suddenly remove that 2 and say it's ion to Br, okay? So, 3 Br2s means there are 6 bromine atoms, okay? So that means we have 2 iron atoms for every 6 bromine atoms, okay? Now, I know I keep banging on about it's important not to confuse the big numbers with the little numbers. You can't just magically, in a chemical reaction, turn a little number into a big number. But this isn't a chemical reaction question, it's ratios, okay? The reason I've removed that 2 and turned it into a 6 is because we're interested in the ratio of atoms here. Okay, I'm not saying by doing that 3 Br2 molecules is the same as 6 bromines, okay? This is purely a mathematical thing to get the ratio of atoms. Okay, so 2 of those to 6 is the same as 1 of those to 3 of those. Okay, we're there. There's 1 ion for every 3 bromines. Okay, so therefore it's that one. It's Br3. Okay, so it's 1 ion for 3 bromines. Okay, good. Right, next question. When iron reacts with bromine, bromide ions are formed. Explain the type of reaction bromine atoms undergo when they are converted to bromide ions. Okay, so it's this reaction they're talking about again. So let's write out the equation so we know what's going on and balance it. So it's iron plus Br2 is making iron bromide. Okay, is that balanced? No, it's not. There's 2 bromines there, there's 3 there. 2 and 3 both go into 6, so we're going to need a 2 there probably to get 6 bromines and a 3 there. Okay, the bromine's balanced now. What about the iron? There's 2 there and 1 there, so if we put a 2 there, then it's all good. Okay, so that's what's going on in this reaction, balanced. So you've got 2 ions, like so. Okay, 3 Br2s, which looks like this. Br2, bromine, elemental bromine is a diatomic molecule. Okay, it's making 2 iron bromides. So it's an iron with 3 bromine or bromide ions, not iron. That's iron, this is an ion. Okay, around it, and there's 2 of them. So there's 1 there, bromine, bromine, bromine. Each of these has a negative charge on it, okay? And the iron is 3 plus, okay? So that has a minus, a minus, a minus, and the iron is 3 plus. All right, so that's what's going on. When you balance an equation, that's what you're really doing. These big numbers that you have to add, it just multiplies the number of these molecules. So you see you've got 2 ions and 3 Br2s. and 2 FeBr3s, one there, one there. Okay. So, the iron bromide, the iron has a 3+ charge, which means it's lost 3 electrons, and it's given those 3 electrons, one each, to the 3 bromines that are ionically bonded to it. Okay? So the question said, explain the type of reaction the bromine atoms, doesn't matter about the iron, it's only 2 marks, the bromine atoms undergo. Well, here, that bromine atom is uncharged, okay? But here, it's got a -1 charge, okay? So that means it's gained an electron. So say that. Say the bromine atom gains an electron, okay? And it becomes an ion. An ion is a charged particle. It's not charged there, but now it's charged. And what type of reaction is this? When something gains electrons, it's being reduced, or it's a reduction reaction. Okay, the bromine is reduced. Okay, so reduction reaction. Only the bromine is being reduced. The iron is being oxidized because it's losing electrons. But you won't get marks for saying that because it's only asking about the bromine. And like I say, always try and say a bit more than you think is necessary, just to be sure, to make sure you get all the marks. You could say this is an oxidation reduction reaction overall, or redox. But you'll already have got the 2 marks by that point there. So redox, oxidation, reduction. Okay, right, finally. That is it, isn't it? I thought there was another question, but there isn't. Fantastic. Okay, there we go.